On to section 6 now of chapter 5, where we're dealing with perfect square trinomials and the differences of squares. Now, in an earlier section in chapter 5, we went over when we would FOIL or do the special squaring of these, and keeping in mind that when we undo it then, that's like a little shortcut. So let's take a look. And these are what we'll be covering. Now, is this, for instance, a perfect square trinomial? Well, there are some things to look at. Is the first term a perfect square? Yes. Is the last term a perfect square? Yes. And both the first and third terms are positive. Now, the middle term could be either negative or positive and still be a perfect square trinomial. Now, the key is if you took the square root of 9, that's 3, and you doubled it, you would get 6. So this is, in fact, a perfect square trinomial, as they are saying, which will factor into two binomials that are exactly the same and often written with this signature. So over here they're giving you some little hints, and by the way, I have passed up on some of these in the past, and they are useful in your textbook as little areas of focus to help you with various things. So here are some of the perfect squares of 1 to all the way through 12. So this would help you recognize what are the perfect squares. If you don't know them already, might be something you would put in your notes. So let's look at this. Example 1. Determine whether each polynomial is, in fact, a perfect square trinomial. All right, perfect square, perfect square. The square root of 25 is 5. If you double it, it's 10. Yes, this is a perfect square trinomial. Now, as you look at letter B, first of all, it's not in standard form, but is this term, which would be the lead term, a perfect square? And the answer is no. So this one is not. Now, here, again, this is not in the correct form. So I would imagine the first thing they want us to do is to put it in correct form. So this is going to be 100y squared minus 180y plus 81. Now, as you look at this, is this a perfect square? Yes. Is this a perfect square? Yes. Now, what's the square root of 100? 10. What's the square root of 81? 9. Now, 9 times 10 is 90, and if you double it, you get 180. So yes, this is a perfect square. And again, they're going through some detail of what I've just done here, but in the sense I'm just reviewing it with you. So again, they're showing you the pattern, that special way, square the first term, you get that, multiply these two together and then double it, and then square the last term. The difference would be that here the middle term is positive, here the middle term is negative. Your end terms are always positive. So, if you recognize that it's a perfect square trinomial, then you might just use this procedure. So the x is going to go there. This negative sign goes there. And the square root of that goes there. And you just check it, and it does check. All right, this is not in correct order. So I put it in standard form. And now I'm going to take the square root of this one. Middle sign is plus. Take the square root of this. Now, notice I get 4 times 7 is 28. And if I double 28, I get my middle term. And the same thing here. We would have to put it in standard form. So I put it in standard form, and I take the square root of this. My middle sign will be negative, and the square root of that is 2y. And if I square this, I get that. If I multiply these together, then double it, I get this. Square this term, I get that. Okay, so again, a strategy if you think you have a perfect square trinomial. Now, for number 3, as we look at it, let's look at it a little bit more here. And it looks sort of strange, doesn't it? Well, first off, there is a common factor in everything. So let's factor, we put it in this order. Let's factor out a negative 4y squared, which we have done right there. Now that we've done that, we need to put what we have in our parenthesis in standard form. All right, this one's a little tricky. And again, it has a 6 there, but 6 is a perfect square, and it ends up looking like this. And it does check. So this is your factorization down here. Notice that you took out a negative here, and you had to reverse all these signs internally in the parenthesis. Okay, going on to another, and by the way, these all were what are called special products. That when you have special products, there is an easy way to undo it if you recognize it. So the special product we're looking at now is this, which is called the differences of perfect squares. And again, in order for it to be this, the first term must be a perfect square, and the second term must be a perfect square, and you're going to have a negative sign between them to give the word difference some meaning. So these are perfect squares, and keep in mind they will factor into their conjugates. A useful word we'll use in later sections. So again, 2 sets of parentheses, square root of that, 3x, 3x, square root of that, 8 and 8. One will be a plus, one will be the minus. Okay, now as you look at this one, is this the difference of perfect squares? And the answer is no. So this is not factorable. Now, what you might do here is rearrange this so it looks like this. 36 minus 4x to the 10th. Now you have the difference of perfect squares, and it's okay to do that. So you will factor it into its conjugates. This is going to be 6 and 6. This is going to be 2x to the 5th, 2x to the 5th. 1 will be plus, and 1 will be minus. Let's go on. I'm surprised they don't mention the word conjugates here. Very useful word. So again, factoring these are perfect squares. There's a difference sign or negative sign between the two. They will factor into their conjugates. And again, they have a nice little way of showing it so you can't go wrong. Remember, when you're doing your practice, you can have the tutorial bars to help you move toward a solution. Now, as we look at example 6, notice it's starting to get a little challenging here, because this is not a perfect square, but there is a common factor there. I can factor out a 5 from this. Then I get the difference of perfect squares and will factor it into its conjugates. And notice the detail they are giving. In example B, let's take a look. This is a perfect square. Can you see there's a common factor of y there that they will factor out right over there? Then you get the difference of perfect squares. So you factor that into its conjugate. But notice this second one here that I've put a second line under. That is still the difference of perfect squares and should be factored some more. This is your final answer. If you stopped here, MathLab is not going to give you credit. Okay? So you have to be careful. This is the sum of perfect squares. That doesn't factor because it's the sum. But the difference of perfect squares does factor, again, into its conjugates. And here they are featuring that too. They're saying the sum of perfect squares is not factorable. I see that's getting a little bit toward the end there. Let's see if I can make that a little better. Okay. All right, let's go on. Now, some of these get rather a bit challenging. Let's look at B over here. And again, they have all of it worked out. There's no way for me to hide that. But as we look at this part, I don't know if you could see it, but this is a perfect square trinomial that they're now putting parentheses around. They're then factoring this into a binomial square and then minus this. So in a sense, you have here a squared minus b squared right here. So then it's going to be this plus the y, and then this again minus the y. And if you have something like that, that's how it's factored. Okay? And in letter B, if you put a parenthesis right there, This is a perfect square trinomial that will factor into B. Well, wait a minute. I think I'm getting ahead of myself. Oh, this one was really tricky. We had to put the parenthesis here. Now factor out a -1. Reverse the signs. Then you have your difference of perfect squares. Wow, that's a little tricky. And we had to look down here to see the rest of this. So there's where they reposition the negative out there after factoring out a -1. Again, that was pretty tricky. And it factors into this, and then these are your final answers. Okay, another little part of this too is solving equations. Now suppose you had something like this. This is a cubic equation, and in order to solve it, we would have to first put it in standard form. So let's just watch it here. And of course, here they're using your graphing calculator. So we get everything over on the left, and then we factor it by grouping. And we had done this one time before. In fact, they're not showing all of that, so let me show it to you. Okay, again, they have most of the steps up here, but there it is in standard form. It's 4 terms. I'm going to factor by grouping, take an x squared out of each of these, take a -4 out of this, and then I get x plus 3, and then bring these in. But this is the difference of perfect squares. I will then factor that into their conjugates. Then I get my 3 answers. So x equals -3, x equals -2, and x equals 2. Okay? And there they are, right there. Okay. Again, you have some challenging work ahead. And let's see if there's anything else here. Okay, they're also giving us one more example. Find the zeros. Again, we're going to factor this by grouping. Again, we get here the x squared minus 1, which is this here, which we will factor into its conjugates. And then you get 2 answers the same. X equals 1, x a -1, x equals a -1, and x equals a +1. So these are the zeros. Now, when we get a repeated root, we say we have a double root. And normally in our answer set, we don't have to list them twice. I'm sorry, the 3 times. We only have to list them once. I was watching something else. So once again, if we have 3 answers and 2 are the same, we only list the 2 same once. Okay, and there it is right there. Example 11, let's take a look at that. As you try to factor that, it's prime. So where you could solve it using a graphing calculator, we just say it's prime and we won't have any basically like that. Okay, this will be a little summary of what we've done, and you'll have your practice and your quiz-mes as we move on to our next topic, 5.7.